So what kind of problems are we going to solve? Or problems from domains like biological sciences? We can have problems from domains from physical sciences, from a domain like behavioral science, or any other related science. So I think this spans every aspect of scientific problems and non-scientific problems as well. If we learn the art of this artificial intelligence, machine learning, and neural networks, this is probably going to help us to solve our own individual problems. Now, these will be the contents of this whole course, and this is a bit scary to some of you, and some of you, this may be a cakewalk. And so, if you have a look at these, so these are the contents of this course. And if you look at the contents, it's an exhaustive list, and there are so many things which you may be aware about, and you may have learned in your high school, or you may have learned in your graduation or after. But when we are going to take these topics, we will take them all under the umbrella and context of machine learning, artificial intelligence, and problem solving. So we will have a more, I hope, a practical approach in order to understand this. Okay. Now this all looks like it's, if you can look at this previous slide, this all seems to be statistical, first page of a statistical book, and yes, it is, and it's quite related. So are we going to learn statistics? Probably yes, and of course, but under the auspices of artificial intelligence, data science, and machine learning, we are going to learn this statistics. So yes, so tighten your seatbelts so that you can take on this statistics. But some of you may not be sure where we are heading, because we thought some of you may have different perception regarding this course, so you are not sure about what we are going to do. So let's give it a try and see where we are heading. Now, this is where we will start. There's a famous concept, or a famous test which we call Turing test. People from computer science background may be knowing about it, or some of them even may not be knowing about it. So let's see what it talks about and how this is going to relate to our own course. Now, there's a concept that's called Turing test. What Turing test is, now what this Turing test is all about, if you interact with two objects, one is human and one is a machine. Now, what do you mean by interact? It means you exchange messages with them, you try to, interact by any other means, or by signs, or by messages, or whatever kind of interaction you would like to have. Then, if the response from the both, that's one of them is machine, but you're not aware which one is machine and which one is human, and the response from the both resemble so much that it's not possible to distinguish which one among the two was a machine and was a human, then what we say is that the machine has passed the test. What kind of test? The test is that the machine has reached the intelligence level of the human. So this is a Turing test. Let's look at it again. If you interact with two objects, one of them is human and one of them is machine, and the response from both resembles so much that it's not possible to distinguish which one is a human and which one is a machine among the two objects, the machine has passed the test and has reached the intelligence level of the human. Now the benchmark in any kind of a artificial intelligence, or in any kind of machine learning project, the benchmark always, you must remember that the benchmark is always human intelligence. We do not want, or we cannot go beyond that benchmark or beyond human intelligence. But believe me, not every human is an intelligent one, and not every machine thus is intelligent. Now, sometimes a human makes a mistake. It's okay. A machine can also make a mistake, right? So this does not If you perform a Turing test on something and on a machine, and you should not expect that there will be no mistakes performed by the machine. It's okay. As humans perform mistakes, machines can also perform mistakes. And we should gracefully accept this notion that we can have mistakes from machines as well. Okay, so how this Turing test is going to help our course? Actually, Alan Turing was the father of artificial intelligence, and even Alan Turing was the father of whole computer science, I should say. So, are machines so capable that we may not be able to differentiate between a human and a machine? Yes, we humans make it so. We can make machines so capable that there's a stage, or then we will come to a stage when we will not be able to differentiate between the two. So we make machines capable, and using some common sense. So we don't need a lot of stuff to understand and a lot of stuff to do in order to make machines, so intelligent. We can do it, yeah, using simple common sense. Okay. So how we do it, by the way? How we make a machine intelligent? We use experiences to make it learn, like we make our children learn from our own experiences, or sometimes we let them experience on their own. As you know, we have children at home, and we we talk to them, and we just make them learn and just share our own experiences with them. And sometimes we don't want to share our own experiences. Sometimes we let them to experience on their own. Can we do it with machines? Yes, we can do it with machines. And if we are doing the same thing with the machines, we formally call it machine learning. So machine learning, nothing, it's just trying, you make the machine to learn. Now, how do you make a machine to learn? Either you share your own experiences with the machine, or you sometimes let the machine experience of its own. Okay, so this is how we make a machine learn. Okay, so where from this, there's a word, if you look at this, we use experiences, right? So what kind of experiences, what this experience is? So we need to we need to discuss about what this experience really means. So what are these experiences? Experiences come from processes, events, or interactions. Any kind of process is going on anywhere in the world, any kind of event is going on, or you are performing an interaction with someone, you are performing a process. Eating food is a process, right? And you're praying, even it's an event, so it should generate something, and you are making interaction with some other person. And as I'm interacting with you, there is some sort of generation. And what generation? They all come, their processes, events, interactions, they all generate data, right? So whether there's a process, an event, or an interaction, what at the end of the day we generate is data. So experiences lead us to the data, right? Data generation. How does data help us? Data helps us to learn the present scenarios, and then by learning present scenarios, we build ideas. And when we build ideas about something, some process or some scientific problem or something related, then we can be prepared for the future. That helps us. So data helps us in 3 dimensions. One, it helps us to learn the present. It helps us to build the ideas. And the third, it helps us to prepare for the future. Right? Okay, so this is how the data is going to help us. So we use this data to make our machines learn, right? Which data? Data generated from processes, events, or interactions, or any kind of stuff. So do all events, processes, and interactions generate same data? Do they all generate same or similar kind of data? Not really. So depending on the kind of process, event, or interaction, or something like that, we can have data, but that data is varied in nature. Different processes generate different kind of data, different type of data, and other things. So the data generated from these sources or really impractical, they are not same, right? So what do we mean by that the data is not same? Data has many characteristics like we humans do, right? We do. Humans have different characteristics. Each one has its own identity, its own shape, its own size, its own nature. So has data. Okay. So this course is, going to do nothing more than making you understand those characteristics of data, right? So what we see, if you can go just a slide back, you know, if you want to make a machine learn, right? We make a machine learn by using experiences, and all those experiences, they all generate data. Okay, the data is going to learn as present, build ideas in future, and then not all data generated is really the same. Okay, so this course is going to help us to understand the characteristics of data. And to understand the characteristics of data, we sometimes call it statistics, right? Okay. So what are the different data characteristics? Let's go straight into the data. What characteristics we look for in a data? We have an acronym SOCS. Everyone may note it. So this acronym stands for shape, outliers, center, and spread. So whenever you look at data, what you are looking at is shape of the data, the outliers present in the data, the center of the data we're trying to find, and spread of the data, right? Now, shape, what do you mean by shape of the data? How skewed the data is, or what kind of distribution the data exhibits. Now, some of you may not be aware about skews and distributions. We will go into detail. That's what we are going to do in this whole course. So we may have a different shape of the data or distribution of the data. Next thing we have is outliers. Sometimes our data may have a number of outliers. What are outliers? Actually, they are the extreme values. They are the values, unexpected values, or the data, or the values which are more extreme, from the center of the data. We call them outliers. So we are looking for outliers. We're looking for the shape of the data. Then the next thing we're looking for is the center of the data, where we can find the center of the data. Center is so important in a data. As the course progresses, you will find it, that how important it is to find the center of the data. So how we do, we have, we have gone through these in our high school, that what's this mean, mode, and median. But when we go here in this course, we will have a different perspective of understanding these mean, mode, and median. So we will look for the center of the data, and where we end is spread. Spread is how spread the data is, right? What's the range, standard deviation, and IQR, that's interquartile range. So some of you maybe, vary about these kind of terms, skew, distribution, outliers, range, standard deviation. Don't worry, we will go by each of these individual terms, and we will take on them and in a very simplified manner. So here comes the role of statistics. If you want to go for the shape, outliers, center, and spread, if you want to understand your data, whatever data you is in front of you, then comes the role of statistics, right? Okay. Then we have, actually, let's understand what statistics is. Actually, we will start straight away with the types of statistics we have. And actually, we have two kinds of statistics. You should know statistics is nothing. It's about understanding your data, right? So we can have descriptive statistics, and we can have inferential statistics. Descriptive statistics is nothing. It's how you describe your data, right? Using like the previous one, SOCS measures, right? Shape, outliers, and we have this center and spread, right? So if you want to describe your data, you use descriptive statistics. And other kind of statistics we have is inferential statistics, based on a sample. You have a sample, and you draw inferences, or you draw some forecasts from that whole population, right? Okay. Then So we have two kind of statistics. One is descriptive and one is inferential. Okay, let's move ahead. We have descriptive statistics. It's used for to describe your data. How do we describe our data? We use measures like measure of central tendency, like mean, mode, and median. And we use measure of dispersion. Measure of dispersion is nothing. It's about how you are going to understand the spread of the data, how spread the data is. A range, interquartile ranges, and we have standard deviation, and we can have variance, right? So this is how what comes under the roof of descriptive statistics. Then we also have another way of describing the data, which you probably will be finding in your newspapers and research articles. You may be finding graph plots, like we have box plots, histograms, and scatter plots, and other plots as well. So in order to understand your data, you can use measure of central tendency, measure of dispersion, or you can use graph plots, and other tabular forms also we have in order to understand our data, right? Okay, so the second kind of statistics which we had is inferential statistics. Just a repeat again, and so some of you may not have gone through it. So statistics was of two types. We mentioned one is descriptive statistics, one is inferential statistics. Descriptive is about how you describe your data, and inferential is about based on a sample you want to forecast about the whole population, right? So descriptive statistics, you use these kind of things: measure of central tendency, measure of dispersion, you use graph plots. And inferential statistics is about you haven't, have some small small amount of available data, and based on that small amount of available data, you want to make projections, or you want to understand how the whole population is going to behave. So common forms of inferential statistics involve how you perform those inferences. You may be using hypothesis testing, you may be using confidence intervals and regressions. Now, don't be worried about, or don't be worried about these kind of terms, hypothesis testing. We will go each of them in detail, and we will do it in a more practical manner in coming sessions. So we have hypothesis testing, confidence intervals, and regression. So inferential statistics is to infer data from the available data as a sample which you have. And so how we do inferential statistics is we use a representative sample. What's the representative sample? It's a sample or a small set of data which will match the characteristics of the whole population. If you have a small sample, you should take a sample which represents as closely as possible. You cannot have 100% representation of the whole population using a sample, but you should try to get a sample as close as possible, right? So once you have a sample, then you use one of those following things, techniques. You can use hypothesis testing in order to infer, in order to be sure about what you are going to infer or what you are going to forecast. And you can also use confidence intervals and regression as well for extrapolation and other things. So let's go ahead. Now, what kind of data we have and what we can really look for in a data is actually a data set is a collection of data stored in a tabular form, and every one of us care about data sets there and there, what kind of data sets we may have. So it's nothing. It's a tabular form of data which comprises of columns. Those columns represent features or the attributes, and a data set has rows or instances. So this is a kind of data set, how a data set looks like. Like I have just made a dummy data set, and you can see we have 5 features in it. Patient name is a feature. Age is a feature, location is a feature, weight is a feature, and height is also a feature. So these are the 5 features of this data set, and we can have different, rows in it. Like we have only 2 rows here, but we have millions of rows in a data set. And we have tens of columns, like we have 50, 60, hundreds. Sometimes we have, features of the columns of a data set. Every one of you from every background, whatever background you are from, you have every time you do need to, make your own data set. You have some well established, or some classic data sets available online as well as offline, and you can use different URLs to in order to access those data sets, and you can perform your experiments on those data sets. Uh, so you don't need to do your own surveys and other things in order to get the data. Sometimes you may, based on your problem and your kind of context, but most of the time, experiments, you can perform experiments on the given data sets which we have on available over the internet, or you can locally get them from different sources. Okay, this is how a data set would look like, and you will perform all of your uh, inferences and all of your descriptions on these kind of data which is available. So just recall these all things why we are doing here, why we are going through these data sets and other things. This is all we want to make a machine learn. That's the objective in your mind right now. You want to make a machine learn. So that's why, in order to make a machine learn, you're just learning these things yourself, right? Okay. So what was the story so far? Let's summarize it. We have processes, events, or interactions that generate data, and we use this data to make machines learn, right? We use this data generated from these sources to machines learn. And this data which we have may exhibit different characteristics, and we use statistics in order to understand those characteristics, right? So this is the short story what we have done. So processes, data, characteristics of data, and statistics in order to help us understand data, right? So let's switch to the classical style of human learning, and we will use a blackboard for this. And I've just kept it very simple. So what we will do, we will try to learn these basic things, and we will try to understand how we are going to use them in our own. We will first start with this descriptive statistics, and we will try to understand the measures of central tendency, how we can find a mean, mode, and median of the data. And then we will move on the measure of dispersion, how we measure the dispersion of the data. And then we will see the plots, what these plots are: box plots, histograms, and scatter plots, and we will get some insights about them. These may be very basic to some of you, and quite ordinary, but I would suggest that you stay with us through these initial sessions, because we will refer them once we move to the advanced ones, and we will definitely have a different way or different perception of understanding these basic things which you may be aware about. So we will move to this the basic style of human learning which we have done in our school. So we will not take a break now. We will straight away go to the blackboard, or Zoom calls it whiteboard. Okay, so let's go for the measure of central tendency. Measure of central tendency. So measure of central tendency, the first and foremost thing of measure when you want to measure the central tendency of the data is mean. What is central tendency actually? A central tendency is where the center of the data is, right? You want to understand the center of the data, because the only thing you can get from a data is a center, right? So for example, example, you have some data. Okay, you have some data, and if this is a data set in front of you, and you have different attributes. Let's say we have an attribute called, we have only two attributes. Let's say we have an attribute that's called age, right? Bear with me with my writing, and this is quite tough to me as well. Right, this is age, and we have some other factor. Let's say we have, so yeah, right. Anyways, so we have different. We have a database where we have age. So we have an age of 2 year old, and what's its height. Okay, so we have it in inches, some values. So we have different values here, and we have different corresponding values here. So for this age, we got, we measure someone's age, and we have someone's age, and we measure his height, and kind of thing. Okay, so what you want to understand is, if someone tells you what kind of data this age is, you want to learn, you want to describe this data, right? How you can describe this data, this age data, you want to describe this, right? So for describing this data, you use, the first thing you will use is the measure of central tendency, right? So you will learn that is central tendency. So what is central tendency? Let's say if I plot this age, for example, I will plot this age like this. Let's say, so for example, the person 1, person 2, person 3, person 4, person 5, person 6, and so on, right? Okay, so this is age. Now person one has some age. Let's say it has 2 year old, and the person 2 has some age of 5 year old, and sorry, height. Sorry, person 2 has this age. Person 3 has this much age. Person 4 has this much age. It's a very old guy, and we have a baby here. We have a person in a mid age, right? So we have different data. Now, what can we do with this data? We just want to understand this data, which is in front of us. Let's do one thing. Let's connect these dots. Okay, let's connect these dots. So the first thing we should do is whenever you have the data in front of you, the first and the foremost thing you should do is you should try to find the center of this data. Right. So what the center of data is? It's the mean, right? You want to find the average height or the average age. What's the average age of this whole data set? Okay. So this average age is here, right? Let me say this is the average age of this whole column, right? Now, why we want to find the mean of this data or the center of this data? We want to find the center. The reason behind this, the motivation behind finding the mean of a data is because there should be a starting point, right? There should be a starting point where from we can start. So that's the first motivation in order why we find the mean of data, right? That's the starting point. We want to have some starting point where we can start our journey to understand it. So that's the first reason. Reason second is that we find the data, mean of the data, because there is tendency of the natural data, right? The natural data, the process which are natural in nature, like the height of the humans, the weight of the humans, like eating habits of the humans, or the height of the animals, and the kind of the rain we have, the data from the rain, the data from the environment, the data from the all natural processes. They have a tendency that they all converge to the center, right? They all converge to the center, right? What does this mean? This means that the data, if you plot a data from a different, from any natural process, it will have a shape like this, a bell shape, right? So what does this mean? It means that what you can see here in this, in this range, you can see the majority of data will be, more close to the center, right? So two motivations for understanding the mean of the data or calculating the mean of data is one, is that we need a starting point, right? And the second, so motivation is we need a starting point. Second motivation is uh, data base. When I say data always, I'm talking about the natural process data always converge. Just to recall why we are doing this all, we are just trying to understand the data, right? We're just trying to learn how to understand the data, or how to describe the data, right? So the first thing is mean, right? And everyone knows how to calculate mean. Mean is nothing. It's, number of items you have and you divide it by n. So some of you may not be aware. It's just the average, right? But the basic motivation is these 2 points, that you need a starting point in order to understand the data. And second important point is data always converge towards the center. So this is why we want to find the center. Now, any kind of measure of central tendency, you can say, any kind of, you want to have the mean, you can use mean, which we mostly use. You can also have mode, right? The other way of measuring the center of the data, and you can have a median as well, right? So there are three ways to measure center of the data, but now we are just focusing on the mean, right? The How we calculate mean mathematically, everyone knows it's quite basic, but still some of you may not be aware. So if we have 10 data items, we just do what? We just add, right? We just add, let's say we have a data item x1 and another data item is x2, right? And then we have another value for the age. Let's say we take an example of age. So we add all those ages, all those values, right? And so on, right? And so on. And what we do, we just divide it all by the n. What's n? N is the total number of items we have, right? So we add these all and we get divide by n, and this is what we call mean, right? This is what we call. Right? So this is mean or average of the data. We add up all individual values and then we divide it by n. And what does it tell us? It tells us where the center of the data lies, right? It just gives an idea of where the center of the data is. And how does this, knowing the center help us? Being a data scientist or being a scientist or anyone related going to solve the problems using data, you should know that the motivation behind finding the mean is nothing, just to starting point. And the second motivation is that the data always converges towards the center. So majority of data you will find will be, in the center. Before we conclude today, we have already exceeded, I think, we're about to exceed our time limit. So just take away that before we conclude for today, and we'll have feedback from you. You can drop your feedback in the WhatsApp group regarding this first session. And if you want any kind of changes in this, we can do it. Before you leave us today, I will just give you an idea of how the center is going to help us. Actually, if you know the center of the data, okay, if we have the center of the data, one thing you should know is that majority of the data lies here, right? Now, what is here? How I bound this area, we will see in the next session. So, if I roughly say you 70% of your data will be around the mean, right? 70% of the data will be around the mean, right? Just in the left and the right of the mean, right? So, calculating the mean will tell you that where is the data, how close it is to the data, right? So this is the motivation. So 70% of data is just converged towards data. It tries to be as close to the mean as possible, right? And that's by nature. There's no, certain mathematical, reasoning for that, but it's natural that 70% of data try to be as close to the mean as possible, right? And we will see in the next session how we can take on other measures of central tendency and dispersion of the data, right? How we can understand the spread of the data using standard deviation. And also we will have these all things done in Excel, MS Excel. I hope everyone has access to the, or has MS Excel or Excel Office installed on their computers. So next time you be with us and try to have a computer with you yourself or around, and so that you can perform some hands-on, because next session we will perform some hands-on in these basic things: mean, mode, median, standard deviation, and variance, and the later things, and try to understand what kind of data we have. Thank you so much for joining us today, and I'm really thankful to Miss Ola. First of all, she's been volunteering for us and trying to ensure that everyone's on board and join this group. And also, I would like to thank Dr. Sami and for being, you know, so prompt and joining us first in the morning, and thankful to other participants as well. And just to inform you that we have participants from different universities and countries, and some very senior members with us, professors and other kind of dignitaries. So I'm thankful to everyone, and please share your feedback, and so that we can have a next session. Not tomorrow, but we will have a session on Tuesday, probably. Right? Thank you so much. Thank you for joining us.